All right, so number one right here, the domain is the x values. So we'll have -1, 0, 1, and 2. I did it from least to greatest. The range will be the y values. Again, I did from least to greatest. So we have -6, -2, 3, and 5. So mapping it, again, did least to greatest, and then I matched up the ordered pairs. -1 to 3, 2 to 3, 0 to -2, 1 to 5, and -1 to 6. That is not a function because we have two x values that are the same number. We have two -1s that are x values, meaning that it is not a function. If you graphed it, those ordered pairs would be stacked. It would not pass the vertical line test. All right, next part, unions and intersections. First, we have the union of A and B. That means we're combining the two sets. So we'll have 1, 2, 4, 6, 7, 8, 9. Combining A and B. The intersection there. The intersection is what's in common between A and B. So that would be 4 and 7. And then we have the intersection of what's not in A and B. So what's not in A, if we look at the universal set, is 1, 3, 5, 9, 10. And the intersection of what's not in A and B would be 1 and 9. Okay, 1 and 9. Five, the union of A and C. We're combining them, so that'll be 1, 2, 4, 6, 7, 8, and 10. Then we have the intersection of B and C. So what's in common between B and C? That's 1 and 4 and 7. Number 7, I'm going to set up a Venn diagram. I got cookies and ice cream. 175 like both. 505 like cookies, so I need to subtract the 175 that like both. So 330 like cookies only. Then I got 415 people like ice cream. I subtract 175 who likes both. That gives me 240 like ice cream only. And then there's 1,000 people survey. So if I add up 330, 175, and 240 and subtract that from 1,000, that leaves me with 255 people who did not like either. 255 people who did not like either. I will be posting this to YouTube, okay? So I will be posting this to my YouTube. Smash that like button. Like and subscribe. You can just type in Stephen Burris Choctaw and it'll come up. If you type in... Yeah, I'll post the link on Focus. But if you just type in Stephen Burris Choctaw in YouTube. All right, 8. This should be... I meant to make it an and in negation of Q. It's an and in negation of Q. So our pattern, we got true, 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 false, false, true, and false, false. Remember, the negation of Q just means the opposite of Q. So that will be false, true, false, true. So then for and, we're just looking at P in negation of Q. And for an and statement to be true, they both have to be true. So true, false, that's false. True, true, that's true. They both have to be true. False, false, false. False, true, false. All right. Again, for and, they both need to be true. Okay? They both need to be true. The next one right here, this is an or and the negation of Q. Quiet. This is or and the negation of Q. So again, we've got true, 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 false, false, true, false, false. And so the negation of Q is the opposite. So that'll be false, true, false. And again, we're just looking at P and the negation of Q. So for an or statement, just one has to be true. Just one has to be true for it to be true. So true, false, that's true. True, true, that's true. False, false, that's the only case where it'd be false on an or statement. And then false, true, we have a true, so that's true as well. Number 9, the converse is it's flipped, right? The converse is flipped. So, if she likes the boy, then she goes on the date. 10, the inverse means it's going to be the opposite. So if I don't hit a home run, then I didn't know what pitch was coming. Then the contrapositive is both. You're flipping it and making it the opposite. So if I did not bump my head, then I am not short. All right, next, here the quota would be 8. There is 6 plus 5 plus 4 plus 3. 18 voters in that system. The weight of voter B is 5. The weight of the coalition A and C would be 6 plus 4, which would be 10. Is AD a winning coalition? 6 plus 3 is 9. 9 is greater than 8, so yes, that is a winning coalition. It needs to be 8 or more for it to be a winning coalition. Which voters are critical voters in the coalition ACD? If you removed A, it would not work. If you removed C, it would work. If you removed D, it would work. So A is the only critical voter there. And the coalitions that can be formed, we got, it's 2 to the nth power, so there's 4 options. So 4 minus 1, 2 to the 4th gives us 16 minus 1, which gives us 15. Bands-off power index. So we need the winning coalitions of A, B, C. So A and B would be 9. That would be a winning coalition. A and C would be 8. That would be a winning coalition. A, B, and C would be 11. That would be a winning coalition. B and C would not work. That would only be 5. So, looking at that, critical voters, the first one, if you removed A, it would not work. If you removed B, it would not work. For AC, if you removed A, it would not work. If you removed C, it would not work. And then for the last one, if you removed A, it would not work. If you removed B, it would. If you removed C, it would. Okay? So that means we have 5 critical voters. So for the bands-off power index, for A, there's 3 A's. So that would be 3 divided by 5, which would be 0.6. B, that would be 1 over 5, which would be 0.2. C, that would be 1 over 5, should be 0.2. Okay. 14's not on your sheet. I'm going to do another one anyways, okay, just so you have this on here. So again, here we'd have A, B, C. A and B would be a winning coalition. A and C would be a winning coalition. And then A, B, C would be a winning coalition. So this is going to be very similar. Here, critical voters, again, would be A and B, would be A and C, because if you removed either one, it would not win. And then it's just A for A, B, C. If you remove B, it would still work. If you remove C, it would still work. So this is going to be the exact same. A would be 3 over 5, which would be 0.6. B would be 1 over 5, would be 0.2. C would be 1 over 5. Would be 0.2 there. Okay, so that one would be the exact same. Didn't even realize that. Okay. Next, I'm going to come back to that. All right, let's do this right here. 15. There are 62 iPads to be apportioned in different classrooms at Choctaw. We have 85 students, 62 iPads. So, first to get our standard we're going to do 85 divided by 62. Gives us 1.37. So Hamilton method, I'm going to divide each of these by 1.37. So Bishop 21 divided by 1.37 gives me 15.3. Burris 23 divided by 1.37 gives me 16.8. Humphreys 19 divided by 1.37 give me 13.9. And then Peters, we got 22 divided by 1.37, which gives us 16.1. So you round down 15, 16, 13, and 16. If we added all those up, 15 plus 16 plus 13 plus 16, that would give me 60, which is not 62 iPads. I need to portion 2 more. And so the highest decimal there is 0.8 and 0.9. So we'll plus 1 to Coach Burris and Mrs. Humphreys. So I would get 17 and she would get 14 iPads, which then that would get us to our 62 iPads. Okay. Jefferson method, I'm going to lower it to 1.3. Okay. Jefferson, I'm going to lower it to 1.3. So this time, Miss Bishop, 21 divided by 1.3. 16. Burris, 23 divided by 1.3. 17.6. I'll do 16.1. 17.6. Oops. 23 divided by 1.3 gives me 17.6. Humphreys, 19 divided by 1.3 gives us 14.6. And then Peters, we got 22 divided by 1.3. 16.9. So if we added that all up, 16 plus 17 plus 14 plus 16, that'd give us 63 iPads. That'd give us one too many. So I'd need to lower that a little bit more, because that's one too many iPads there. That would give me 63. So we'd want to redo that again with like 1.28 or something like that, okay? To try and get it to be exactly 62 iPads. All right. And last one, this isn't on your sheet, but I wanted to go over it. All right, before we go here. So remember that when we do the plurality method, we're just counting up the number one votes, right? So picnic would be 10 plus 6, 16. Water skiing at the lake would just be 18. Amusement park would be 28. Riding horses would be 16. Dinner cruise doesn't have any first place votes. So amusement park would win plurality there. For the boredom method, we apply points. Since there's 5 options, 1, 2, 3, 4, 5. First place votes, you multiply by 5. Second place votes, you multiply by 4. Third place, multiply by 3. Fourth place, multiply by 2. Fifth place, multiply by 1. So, picnic would be 16 first place votes would give you 80. 18 times 4 gives you 72 second place votes. Third place, 28 times 3 gives you 84. And then fourth place, 16 times 2 gives you 32. They don't have any fifth place votes. So that gives you 268, okay? So next, water park, or water skiing at the lake, I'm sorry. First place, they've got 18. So 18 times 5 gives us 90. Plus. Second place is 6. So 6 times 4 gives us 24. Plus third place, they've got 26 times 3, 78. And then no fifth place votes. So 90 plus 24 plus 78 gives us 192. Amusement park is 28 times 5 is 140 plus 26 times 4 for second place, 104. They've got no third, no fourth. They've got 24 fifth place. So 140 plus 104 plus 24 gives us 268. Riding horses at the ranch. First, they got 16 first place, so 16 times 5 gives us 80. Plus, they don't have any second place. Third place, they've got 6, so that'd be 18. Fourth place, they got 18 votes, so That's 36. And then fifth place, they've got 38 fifth place votes. So 80 plus 18 plus 36 plus 38, 172. And then dinner has no first place votes. They've got 28 second place, so 28 times 4 is 112. Plus third place, they got 18 times 3, 54. Plus fourth place, they've got 16 times 2 is 32. Plus fifth place, just 16 there. So 112 plus 54 plus 32 plus 16, 214. So picnic and amusement park would tie in the Borda method. Okay.